There are different types of t-test, but we are going to discuss only two. The first one is hypothesis about means. It is used to compare a sample mean and a population mean. Now, this is the formula used to compare these two means. T is equal to x over bar minus mu all over s divided by the square root of n. X over bar stands for the sample mean. Mu here stands for the population mean. S, on the other hand, stands for the sample standard deviation. And n stands for the sample size less than 30. Now let us go to the example. According to the Department of Education, junior high school teachers work at an average of 40 hours per week during the school year. The head of the research department of PCP surveyed 25 randomly selected teachers and found out that they work an average of 43.5 hours per week, and the standard deviation was 2.5 hours. Let us test if the mean number of hours worked by teachers in PCP differs from the national average. Use 1% level of significance. Now, the first step is to formulate the null and alternative hypothesis. Our null hypothesis is the mean number of hours worked by the JHS teachers in PCP is the same with the national average, or the mean is equal to 40, while the alternative is the mean number of hours worked by JHS teachers in PCP differs from the national average, or mean is not equal to 30. The next step is to determine the level of significance. Now, the alpha level of significance as given is equal to 0.01 or 1%. Now, since our alternative hypothesis is non-directional, that means we will use a two-tailed test. For the test statistic, since our sample size is less than 30, we will use t-test. Now, if we are going to use t-test, we will determine df. df for this case is n equals 1. Our n here is equal to 25. This is our n. So we are going to subtract this by 1. So our df is equal to 24. Now let us determine our critical regions. Remember, we are going to use a two-tailed test. That is why we have critical regions. So to determine, let us go back to the table of critical values. So again, we will use a two-tailed test, and then the level of significance is 0.01. Our df is 24. That means our critical value is 2.797. So again, this is a two-tailed test. That is why we will have a negative 2.797 and a positive 2.797. So the critical regions are t less than negative 2.797 and t greater than 2.797. That means if your computed value is less than negative 2.797 or greater than 2.797, you will reject your null hypothesis because the computed value in that case lies in the region of rejection. Now let us go to our computation. Let us determine the given values. 40 here is the population mean, 25 is our n, 43.5 is the sample mean, and 2.5 is the standard deviation. So this is our formula. T is equal to sample mean minus population mean all over standard deviation over the square root of n. So substitute the given values. We now have 43.5 minus 40 all over 2.5 divided by the square root of 25. Now the first step is to subtract 43.5 and 40, and then we will get the square root of 25. So 43.5 minus 40 is 3.5. Then the square root of 25 is 5. Then after that, we are going to divide 2.5 by 5. So we now have 3.5 divided by 0.5. Then 3.5 divided by 0.5 is equal to 7. This is now our computed value. So if you can still remember, our critical values are negative 2.797, 2.797. So our computed value is greater than 2.797. Remember that, greater than. So our decision now is to reject the null hypothesis and accept the alternative. Now this is our decision and conclusion. Since the computed t-value 7 lies in the region of rejection, the null hypothesis is rejected in favor of the alternative. There is sufficient evidence that the mean number of hours worked by the junior high school teachers of PCP differs from the national average.